Hello, again me, showing you another motion control system using stepper motors. This time I'm using a clear path stepper motor and drive into a single unit. So this stepper motor is configured using this little handy software. The stepper motor is set to be connected as a step and direction setup with no homing, 800 pulses per revolution, and I have connected that to a S7-1200 Siemens PLC. The cool thing about Siemens is that it comes with built-in motion controller. So in the technology objects, you can add something like this, right? You can add motion control, PID, Synaptic technology, all this. Now, this little PLC comes with pulse train output. So you can have in the PLC configuration, see that? Let me open up the device configuration here. So when you click on that and you click on the properties, you can enable the pulse train output, right? And you can designate which output goes to which. You can have up to 4 different accesses. So this PLC has high-speed pulse train outputs. And you can have up to 4 accesses, right? Along with homing and limit switches. So you will configure it here. You'll say the pulse output is going to be Q0.0 and the direction is going to be Q0.1, right? Which is where I wired the servo, the stepper. So the stepper from ClearPath has this Molex connector, right? And it's set up this way. So you have the enable, the pulse and direction, and a feedback, high level feedback. And this is just a signal to tell the PLC that the servo, the stepper, is ready. So all that goes in here, right? The general settings here, which is the pulse train, and if it's going to be just like ClearPath setting, pulse and direction, pulse and direction. So pulse A, direction B, just like the ClearPath servo. And under the configuration of the technology object here, you open that up and you look at the configuration of the technology object, you see all the settings. General setting is it's going to be a pulse train output, right? And then the drive, this is how it's set up. The drive's name is pulse_1. And then it's a step. It goes into Q0.0. Direction is Q0.1. The active direction, the direction is used. So I'm using pulses and direction. And then the enable is Q0.2. So this drive is enable. That's to have a save torque off, right? So if you want to disable the drive, the stepper because e-stop or something, you could disable it using the enable. And the feedback is on I 0.1, which is the high level feedback from the ClearPath servo. All that is wired to the PLC, along with a home switch here. So the homing, well, the homing is done here. You designate which address is going to be the homing. So in my case, 0.0 is enable. 0.1, 0.0 is the ready from the clear path, and 0.1 is the home switch. And the home is set up in the negative direction, so it's going to home to minus. And then it's going to approach with this velocity, and the homing velocity is going to be 2.5. So it's going to slow down, and it's going to approach bottom side of the switch. So that's pretty much it. And in the logic, let me just minimize that. In the logic, I just have a few wrongs. Like this is the first wrong here. The power function. So you just add this function from your catalog, from the instructions toolbox. You got a basic instructions, now you got a technology, and under technology, motion control, you see the MC power, MC home, MC move absolute, and relative, and jog, and dynamic change, and right parameter, whatever. Everything is here on this toolbox. So I added the power function, and of course it instantiated a DB, in this case is DB5, and access 1, and you enable it. So you can hear it. So like right now it's enabled, and you can verify that on ClearPath software here, disable as enabled. So if I were to just I'm trying to split the screen here, so bear with me a minute. I want to try to split the screen this way. Not that easy. Apparently I need to click that, and then yeah, like that. All right, trying to shrink this a little bit more. I'm going to actually collapse that and probably move this over here so I can shrink this a little bit to show you the ClearPath software little widget. All right, so right now the ClearPath stepper is enabled. If I were to toggle this bit here, just toggle it, modify to 0. It's disabled, right? So first thing, have an e-stop or whatever, power up the machine. The first thing you need to do is enable it. There, it's enabled, right? You can verify. That's from the USB port on the servo. You don't need that in action running, but it's useful for the for showing you the actual status of the servo. All right, so I'm gonna go ahead and home the axis. So the axis is all the way up to the very end. I'm gonna home it by toggling this bit here. It's gonna go slowly until the home limit switch is made, and it's gonna have to like chamfer the cursor here. So create like a chamfer on both ends. So kind of like a cam. So it's gonna go over and there. And now the axis is home. And I just made a little logic below it. So if the home is done, it's gonna reset that bit. Now I have position and velocity. I want to jog the axis to 150 millimeters, right? So the stepper pulses 800 times per revolution, and the screw is 16 turns per inch. Now convert that into millimeters, and you get, I believe it's let me see that. So it's, let's see that. No. It's 25.4 divided by 16 turns. So yeah, So every turn will move the axis 1.5875 millimeters. So all that goes into the setting of the servo here. I mean the stepper. So all you need to do is set those general attributes, right? So it goes into mechanics. So that's what I put in 800. And what do I get? 800. 800. It's from the ClearPath servo. So from the software, 800 pulses per revolution, and this is the number I got from it. And then the load measurement per motor revolution is 1.5875 millimeters, right? So it's both directions. And it's not inverted because I didn't invert it here. It's not inverted here, and it's not inverted here. So now that I homed the axis, I'm gonna move it to 150 millimeters. And pretty much it's gonna be, let's see that, it's about there, right? So it should end over here. Let me turn on that. Modify to 1. It's almost there. So, and I can jog it back to 75 millimeters. All I need to do is change this watch table here. So 75, write it, and then I need to toggle that bit again. So there it is, simple axis. Now it looks kind of cheap because the purpose is I should not spend any money on it. It has to be done with whatever I have at hand, because this is just to test the functionality. This is mostly for programming. But if I were to buy an axis, a linear axis from eBay or Amazon, I could, made of aluminum extrusion or a more solid, beefed up linear bearing or whatever axis to actually build something. So the interesting thing is that you can use this even this cheaper stepper drivers, right, and a stepper like this. So I can use this other linear axis with the same PLC, right? You can have up to 4, so you can build a pick and place out of a simple S7-1200 PLC, and you can have a structure where X and Y or X and Z or whatever values are stored into an array, and you can like create a Cartesian loader, gantry loader, or pick and place, if you will, without buying any extra expensive hardware. I mean, all you need to do is Step 7 1200 PLC that comes with 4 axes built in, which I think is really cool. So that much bigger PLC from Rockwell, it's bigger in size, doesn't have any motion control built into it. No, unless you add IOs to it, that high speed. But this one here has built-in analog high-speed counters, high pulse train output up to 100 kilohertz. So it's pretty neat from Siemens, all in a smaller form factor. And I just prefer Siemens over Rockwell. That's my thought. So stay tuned for more. Thank you.